This is Chapter 1 of HL and SL Chemistry, Models of the Particulate Nature of Matter, Chapter 1, Subsection 1. What does a molecule consist of? A molecule consists of electrons. Electrons are negatively charged particles that orbit around a positively charged nucleus. The nucleus gets its positive charge from protons. Protons are positively charged particles with mass that contributes to a molecule's atomic mass. In addition to protons, we have neutrons. Neutrons are also found in the nucleus. They contribute to mass, however, they have a neutral charge. Elements are identified by the number of protons they have. This means if you ever see a change in the proton, you know you have changed the element you are now looking at. There are many complex interactions that are involved with the positive charged protons as well as the negatively charged electrons. It is important to remember that electrons' negative charges repel each other, and the proton's positive charges are what attract electrons. This is why we only see a certain number of orbitals for a specific number of protons. There is not enough positive attractions to hold the negative electrons. This is because the negatively charged electron shell would repel any incoming electrons. How does matter differ? We have three forms of matter: an element, a mixture, and a compound. An element is the simplest form of matter in chemistry as it consists of only a single element. A compound is a little bit more complex, and this is because it consists of one identical molecule in a particular area of space. Now, this is going to contain one, two, or multiple elements in the compound. However, there is not different molecules within the same space, because if there were, it would be called a mixture. And a mixture can contain an element, a compound, or multiple compounds and multiple elements all occupying the same space. This is going to be the most complex form of matter and the most consistent in reality. Now, how are mixtures different? We have two forms of mixtures. We have a heterogeneous mixture and a homogeneous mixture. A heterogeneous mixture is going to be non-uniform and have an unequal distribution of the compounds within the mixture. An example of this would be sand and water. You know it's heterogeneous because you can still see the sand molecules within the water. Now, this contrasts with a homogeneous mixture, such as sugar and water, because there is a uniform, equal distribution of the sand molecules within the water. If you can see a clear separation in layers between the two compounds, it is pretty evident that it's going to be a heterogeneous mixture. It is also very important to note that mixtures do not only come in liquid form. Mixtures are also in both the gaseous and solid states of matter. Another area of this chapter is solvation. Now, solvation involves a lot of intermolecular forces. This image in front of you is the solvation of table salt in water. The table salt is represented by the sodium and chloride ions. Now, sodium and chloride form a very strong ionic bond. However, when placed in water, it dissolves. This is due to the partial charges of water, which, if you remember, is partially due to hydrogen bonding. Now, this is because oxygen is a very electronegative molecule. This means that it's going to have a higher tendency of maintaining electrons within its orbitals. This creates a partial negative charge on the oxygen and a corresponding positive charge on the hydrogen. It is also important to remember with solvation that in general, polar solvents are what are going to dissolve polar solutes, and then nonpolar solvents are going to dissolve nonpolar solutes. In this example, we can clearly see that the negative chloride anion is attracted to the positive hydrogens within the water molecules. This is what allows the separation between the sodium and chloride anion. In addition, we can see the partial negative oxygens interacting with the positive sodium molecule. Now, solvation might seem very complex, but if you can remember the general law that polar solvents are what are going to dissolve polar solutes and nonpolar solvents are what are going to dissolve nonpolar solutes, it's a lot more approachable. Another concept within this chapter is changes in states of matter. In very simple words, a change in a state of matter is due to a change in a molecule's movement. If you look at the bottom left portion of the figure, you can see a crystal lattice formed from a solid. This lattice is very strong, and it has a very uniform shape, a very fixed structure, and a very fixed volume. As you increase the temperature, you're essentially increasing the movement of the molecules. This is also known as increasing the kinetic energy of the molecules. As this energy increases, you get more separation, and is why you form a liquid when you heat up ice. You can then further heat up the liquid and form a gas, and this is when you increase the kinetic energy even further. Another way you can induce a change in the state of matter is through pressure. If you increase the pressure, you're going to increase how close the molecules are together. This is how you can form a liquid and a solid from gas. You can either decrease the temperature or increase the pressure. If you remember that going from solid to liquid to gas is either done through decreasing the pressure or increasing the temperature, and going from gas to liquid to solid is done through increasing the pressure and decreasing the temperature, you're going to have a pretty good understanding of how you change a state of matter. Within this video, we reviewed the general principles of molecules. We know that they consist of negatively charged electrons, which orbit around a nucleus, as well as positively charged protons, which are confined in the nucleus with neutrons. Now, both protons and neutrons contain mass. Protons are what are able to identify a molecule. We have also learned the differences between matter. We know that an element is just what we see on the periodic table, while a compound is a molecule that consists of one or two elements. And then a mixture is multiple molecules, or a molecule and element, or multiple elements. Solvation is the process in which something is dissolved in a solvent. And we need to remember that like dissolves like. If you have a polar solute, it needs a polar solvent. If you have a nonpolar solute, it needs a nonpolar solvent. Now, in fancy terms, this is known as the dissociation of a solute. As well as states of matter, kinetic energy of a molecule is essentially how much it vibrates and moves. If a molecule is vibrating and moving more, you know that it's either going to be in the gaseous and liquid state. If a molecule is vibrating less, it's going to be in a liquid or solid state. Changes in phases are going to be due to changes in temperature and pressure. With these fundamental states of matter, and reading a states of matter graph is going to be a little bit easier. We also learned in which mixtures are different. Homogeneous mixtures are uniform. Heterogeneous mixtures are not. Heterogeneous mixtures often form layers which show separations between the two compounds. Homogeneous mixtures do not.